Till I see the light, I'm feeling high. My little lady, I'm gonna take it to the other side. You know I used to smoke too much. You know I used to drink too much. Take a ride in my car, you can get me high, high, high. You know I used to smoke too much. And you know I used to drink too much. Take a ride in my car, we're gonna get real. I'm feeling good, my little lady. She's gonna take me to the other side. I'm feeling nice, my little lady. She's gonna keep me moving on. I'm gonna run till I drop to the break of dawn. Never gonna stop, she's gonna treat me right. I'm feeling good, my little lady. She's gonna take me to the other side. You know I used to smoke too much. And you know I used to drink too much. Take a ride in my car, and you can get me high, high, high. You know I used to smoke too much. And you know I used to drink too much. Take a ride in my car, and we're gonna get real. Come on, baby. Let's take a ride. I don't know where we're gonna go, but first, let's dance. You know I used to smoke too much. And you know I used to drink too much. Take a ride in my car, and you can get me high, high, high. You know I used to smoke too much. And you know I used to drink too much. Take a ride in my car, and we're gonna get real. Oh. I'm feeling high, my little lady. I'm gonna take it to the other side. I'm feeling strong, my little lady. I'm gonna keep her moving on. I'm gonna run till I drop to the break of dawn.
Giottos is so good. These chocolates are what? Chocolates. We're here about astrophotography. What are we doing? Wrong video. Whoops.
What have I done? Ooh, what have you seen? Early at night, got in the fight, in the candlelight, looking through the screen. Now what have I done? What have you seen? You know there's no future in love when a person has come in between. Jamie's gone, Jamie's gone. Can't look back and now he feels so strong. Jamie's gone, Jamie's gone. Left last night and now it's been so long. What have I done? What have you seen? There was nothing to say, took her away, and I feel the pain, made love in vain. Oh, oh, what have I done? What have you seen? She knows there's no future in love when a person has come in between. Jamie's gone. Jamie's gone. Can't look back, and now he feels so strong. Jamie's gone. Jamie's gone. Left last night, and now it seems so long. Ooh. You can't hear these words I say when you're a million miles away. Yeah. Jamie's gone. Jamie's gone. Can't look back, and now he feels so strong. Jamie's gone. Jamie's gone. Left last night, and now it seems so long. Jamie, come on, Jamie. Yeah. And now you feel so strong. Jamie, come on, Jamie. Yeah. Left last night, and now it seems so long.
What the hell's wrong with my telescope now? What's wrong with this thing?
The lost Lone Ranger, can I break this spell? I do one thing right, I make two things wrong. If I want that fine line, I'll always take the fall. If I just do step, I can hear from the right. I sleep all day long, then I dream down through the night. I've seen a lot of bankers, and I've seen a lot of cops. I've seen a lot of lawyers pull out all the stops. I've seen a lot of children with their parents in their hands. I've felt a lot of women who refuse to understand. Well, I don't think I understand why we're making such a fuss. And I don't think I understand what's come of all of us. And I don't think I understand why we take the world for granted. I just want to get right back to Guitar Players Planet. You see it in the papers, you read it every day. The riots and the fires going on in South LA. The muggers and the government They're all wanting the same thing. They take you for your money and whatever else bring. And I don't think I understand why we're making such a fuss. And I don't think I understand what's come of all of us. And I don't think I understand why we take this world for granted. I just want to get right back to Guitar Players Planet. Take me. And I don't think I understand what's come of all of us. And I don't think I understand why we take this world for granted. I just want to get right back to Guitar Players Planet. 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 It's gotta mean something. It's gotta. All right. Where did my color go? Got your head in the sand. You can't be in control, using a powerful hand. I wanna be ya, I wanna see ya. Don't taste the kisses of hate. Don't try to tell me, don't try to sell me, don't try to say it's too late. You're gonna push me to the edge, back me in a corner, making me stand in your shoes. Push me to the edge, hide a little color, it's black and white and blue. Black and white and blue, yeah. All right. Yeah. Cat learns to ring a bell. Rat gets free from the maze. We can be taught to love. We've got to learn a new way. I wanna see, I wanna be. Don't taste the kisses of hate. Don't try to tell me, don't try to sell me, don't try to say it's too late. You're gonna push me to the edge, back me in a corner, making me stand in your shoes. Push me to the edge, add a little color, it's black and white and blue. Black and white and blue. wanna see. Don't taste the kisses of hate. Don't try to tell me, don't try to sell me, don't try to say it's too late, late. Push me to the edge, back me in a corner, making me stand in your shoes. Push me to the edge, hide a little color, it's black and white and blue. Yeah, black and white and blue. You're gonna black and white on the edge, back me in a corner, making me stand in your shoes. Push me to the edge, hide a little color, it's black and white and blue. Black and white and blue. Another man come around today, gonna mess with my dream, gonna take it all away, take it all away. I'm just a boy with nothing to lose, got my head in the news, got a bad attitude, yeah, take it all away. So I play guitar. Another woman come around today, she wanna slice on my pie, she gonna try to lock me all the way, lock me all the way. I'm just a boy with nothing to lose, got my head in the news, got my bad attitude, yeah. I don't care, 'cause I got nothing to lose. I don't care, 'cause I won't let them bring me down.
So it's a wonderful night tonight. It's really good. You know, cloudy nights and not cloudy nights, but clear dark sky and you know, was it clear outside? Says it's going to be a wonderful night tonight. I mean, tonight, last night was wonderful. Tomorrow's supposed to be great. So I think I'm going to leave my telescope out all night, and it's going to be a really nice night tonight. So I'm hoping to get some really good shots of the Cave Nebula, which is part of my astrophotography meets D&D imaging. I know it's kind of looks scary, like the way I look at my eyes, kind of crazy. It's pretty cool, but I'm super excited for tonight, and let's see what kind of data I got. Well, yeah.
Dirty. I swear to God, these clouds are just pissing me the off. I don't understand. I don't listen to these things anymore. I can't take it. New York, you suck. And you know what? I'm so done with all this. My telescope's out here chilling out, and all I got is freaking clouds and PhD beeping at me for no goddamn end. Unbelievable. What am I gonna do? I need to move. I'm so finished with this. I hate this.
I've seen a lot of bankers, and I've seen a lot of cops. I've seen a lot of lawyers, pull out all the stops. I'm feeling high, my little lady. I'm gonna take it to the other side. I'm feeling strong, my little lady. see the light. I'm feeling high, my little lady. I'm gonna take it to the other side. You know I used to smoke too much. And you know I used to drink too much. Take a ride in my car. You can get me high, high, high. You know I used to smoke too much. And you know I used to drink too much. Take a ride in my car. We're gonna get real. Oh, I'm feeling good, my little lady. She's gonna take me to the other side. I'm feeling nice, my little lady. She's gonna keep me moving on. I'm gonna run till I drop to the break of dawn. Never gonna stop, she's gonna treat me right. I'm feeling good, my little lady. She's gonna take me to the other side. You know I used to smoke too much. And you know I used to drink too much. Take a ride in my car. And you can get me high, high, high. You know I used to smoke too much. And you know I used to drink too much. Take a ride in my car. And we're gonna get real. Come on, baby. Let's take a ride. I don't know where we're gonna go, but first, let's dance. You know I used to smoke too much. And you know I used to drink too much. Take a ride in my car, and you can get me high, high, high. You know I used to smoke too much. And you know I used to drink too much. Take a ride in my car, and we're gonna get real. Oh, oh, I'm feeling high, my little lady. I'm gonna take it to the other side. I'm feeling strong, my little lady. I'm gonna keep her moving on. I'm gonna run till I drop to the break of dawn.
Giottos are so good. These chocolates are what? Chocolates? We're here about astrophotography. What are we doing? Wrong video. Whoops.
What have I done? Ooh, what have you seen? Early at night, got in the fight in the candlelight, looking through the screen. Now what have I done? What have you seen? You know there's no picture love when a person has come in between. Jamie's gone, Jamie's gone. Can't look back and now he feels so strong. Jamie's gone, Jamie's gone. Left last night and now it's been so long. What have I done? What have you seen? There was nothing to say, took her away, and I feel the pain, made love in vain. Oh, oh, what have I done? What have you seen? She knows there's no future in love when a person has come in between. Jamie's gone, Jamie's gone. Can't look back, and now he feels so strong. Jamie's gone, Jamie's gone. Left last night, and now it seems so long. Ooh. You can hear these words I say when you're a million miles away. Yeah. Jamie's gone, Jamie's gone. Can't look back, and now he feels so strong. Jamie's gone, Jamie's gone. Left last night, and now it seems so long. Jamie, come on, Jamie, yeah. And now you feel so strong. Jamie, come on, Jamie, yeah. Left last night, and now it seems so long.
What the hell's wrong with my telescope now? Yeah, what's wrong with this thing?
The lost Lone Ranger, can I break this spell? One thing right, do I make you two things wrong? If I want to stand by the line, I will always take the fall. If I just do left, I can hear from the right. I sleep all day long, and I'm breathing through the night. I've seen a lot of bankers, and I've seen a lot of cops. I've seen a lot of lawyers pull out all the stops. I've seen a lot of children with their parents in their hands. I felt a lot of women who refuse to understand. Well, I don't think I understand why we're making such a fuss. And I don't think I understand what's come of all of us. And I don't think I understand why we take the world for granted. I just want to get right back to Guitar Players Planet. You see it in the papers, you read it every day. The riots and the fires going on in South LA. The muggers and the government, they're all wanting the same thing. The tick for your money, I would every spring. Well, I don't think I understand why we're making such a fuss. And I don't think I understand what's come of all of us. And I don't think I understand why we take this world for granted. I just want to get right back to Guitar Players Planet. Take me. And I don't think I understand what's come of all of us. And I don't think I understand why we take this world for granted. I just want to get right back to Guitar Players Planet. 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 Guitar Players Planet.
Hello there. How are we doing, everybody? And the illusion of my death is untrue. I am still alive, you know, I'm barely still alive. But we're here today with Rumen from Indigo Astronomy. He has been on a long time ago, but you know, we finally got a chance to catch up. But before we get into this, I just want to stay on track with everything as far as everything is concerned about the business and stuff like that. So, and Scott, if you could hear us, please fix your audio because you have no audio. So that's why you're not on the screen yet. So, and it looks like you're just looking into space. So, how's it going, everybody? What a week. Everybody knows that's on the Discord channel that I've been on jury duty for the past week. So I have been out of commission. So thank you to Dave and to Eric for leading the AstroWorld charge. And I'm sorry if the dogs are bothering us because I'm going to close the door and they can bark to themselves. You know, and it's been an interesting process. So, but today we're going to be talking about Indigo Astronomy. And before we get to that, I just want to do what we haven't done in a while, and I'm just going to roll this real quick to say a quick thank you to all the members that we have. And there's Scott. We got all these members now, and we got more that I got to add. But thank you so much to everybody for your support on Patreon. Take a look at the Patreon account because there's a lot of different tiers and a lot of different things you can get with the different tiers, including Starfront data, which this week has been a very washout in Texas, if you've been watching the forecast. So a lot of crazy storms going across the north part of Texas, which is right where Starfront is. So we haven't gotten much this week, but it's going to be a really awesome week next week. So what the extended forecast looks like. So if you get into the certain tiers, take a look and see there's standard data sets, there's premium data sets, and there's image requests for you crazy people. So thank you everybody for all the main sequence members, the Red Giant members, the Quasar, the White Dwarf, the Off the Rails. Thank you so much, our Protostar members as well. And if you want to get involved, go to the Patreon account. Check us out at AstroWorld TV on Patreon, and get involved, because we're starting to put some blogs and stuff up in there, and it's going to be kind of cool. So thank you, everybody, for your support. Appreciate that. And Scott, do you have a microphone yet or no? And you're still not saying anything. Okay. Anyway, Scott, if you got to say something so I could hear you. So I can't. It's not us, Scott. It's you, because we're good here. Hold on.
Can't hear you.
You know what? I know what it is, Scott. I know what. Give me a second, because I switched you to a new number. So give me 1 second. Scott, audio source. Yep, that's on me. You should hear us now. And okay.
Can't hear him yet.
Not yet, but getting there.
Get the dog out of here. Just give me 1 second with Scott real quick. Scott, you there?
Can you hear me?
There you go.
Yay!
That was not you. It was me. So okay. I gave Scott a new number because I kind of coordinated some new numbers. So there we go. So Rumen, thank you so much for coming on the show again. I know for those of you that don't know, Rumen is out in Europe, and it is 3:08 a.m. over there or thereabouts. Thank you so much for hanging with us again. And
Thank you for hearing me.
It's going to be great to know what's going on with Indigo, because it's been a while. So I'm sure there's plenty of updates and plenty of new additions to the program. We're all really looking forward to kind of hearing about it. So I'm sure there'll be plenty of, we got coders and writers in the chat that will definitely have some questions to throw out to you. So I hope you got your coffee. Yeah. So for those that are new to the channel, and those are, don't know about Indigo, why don't you give a little brief background about yourself, Indigo, and what it does?
Well, a little bit background about me. I'm a PhD in astrophysics and a master's in software engineering. So I try to combine both things, and Indigo was something that combines my passions about astronomy and my passion about software development. So this is what I did. So it's a joint project between me and Petar Polakovic. He's from Slovakia. We never met in person, actually. We chat every day, but never met. So
that's funny.
So,
isn't it amazing though that you could sit there and do something like this, and not only having a show from one side of the world to the other, but building a software project together and not having even met each other.
Yes, it's amazing. Actually, it's amazing, and the story was very interesting, because I was developing link guider software for guiding in the past. It was something in 2010 with a Russian guy, and I wanted to add drivers for attic cameras, for the attic guider cameras. And I contacted Attic, and they said, there's a guy in Slovakia who is developing an SDK about SDK for software development kit for our cameras, for Linux and Mac OS. He can help you with this, and this is how I met Petar. And after a while, we decided that we'll do something new and something interesting that I'm going to present today.
That's awesome.
So everything started online, actually. Yeah. So let me share my screen and proceed with my quick. I'm not going in too much details about the architecture of Indigo, because in my previous appearance I talked about the infrastructure, about everything. Now I'm just going briefly to mark the things for the ones that for the newcomers, and just to remind what it was for the guys that have been the previous time here. So
Okay,
let me just
great.
share my screen. Where's that toggle screen sharing? Probably it's this one. Select entire screen probably.
Yep.
Hello.
Yep.
Yeah, and
There we go. Perfect.
do you
Let me
see
get
my
the-
screen?
Yep. And,
Yep, you're great.
Okay. So, what is new since 2023 in Indigo framework? Well, I'll start with part one. What is Indigo? As I mentioned earlier, Indigo is a software framework for controlling astronomical equipment via software bus. This means that all the devices are connected in a communication bus, and they talk to each other. They can talk to each other. They're controlled via properties which are defined for each device, and they're in three groups: mandatory, optional, and device specific. For example, the camera is obliged to make exposure. So exposure property is mandatory for the CCD camera. For example, gain is not mandatory. It's an optional, because some cameras might have controllable gain, others cannot have. So this is why this is an optional property. And device specific, for example, let's say, well, I cannot think of anything good, but for example, shutter is a standard property. Something like, let's say, fan speed or something like that, that is not relevant to the operation of the camera, and very few cameras have these specific properties. The communication between the different entities attached to the bus. By entity, it's you understand device, software piece, or anything else that can talk to the bus, is achieved via messages which contain property events, the ones that I mentioned above. It's definition, update, and deletion. For example, definition is when a new device appears on the bus, it defines all its properties. It says what can this device do. And if, for example, you change the camera resolution, the device sends update to this property, camera resolution. And when the device goes offline, all the properties associated with this device are deleted. These are separate events that are sent to the bus. So one can think of the properties as both variables that hold some information about the piece of hardware. For example, the camera resolution can be looked at as variable. For example, 600 by 800, but you can change it to 1600 to 8000. So when you change the value of this variable, you change the resolution of the camera. Well, obviously there are some values that are valid and some values that are not valid, but nevertheless this is variable. And properties can be seen as routines. For example, take exposure with 5 seconds long exposure. This is a routine because it's a lengthy operation that needs to complete some action before it returns some results. This is basically what Indigo is. It's a message bus. And how it looks like. For example, we have this Indigo communication bus, and on this bus we have different entities attached. For example, we have a CCD camera right here. By the way, do you see my mouse?
Yep.
Yeah. Yep. Okay, so I'm using it as a pointer. Okay. You can. We have a CCD camera here. We have a filter wheel here. We have a focuser, and this guy here is an agent. In Indigo, we have drivers that talk to the hardware devices, but also we have agents that control the devices. They incorporate in themselves the business logic. So we have different sorts of agents, and in this example, we use only the imager agent, who is responsible for choreographing all these devices that we have on the bus. And at some point, we have a client. This guy here is the client, and the Linux and Windows client, the official clients for Indigo, is called Ein. And Ein comes to joins the communication bus and says, "Hello, I'm Ein. I'm a client, and I want all the properties of all the devices that are on the bus, so that I know what I can achieve with this infrastructure." And all the devices at this point, when the client requests property enumeration, all the devices will define their properties as I explained earlier. For example, the camera will say, "I'm ASI 71 camera. My resolution is whatever. I can take exposures from 0.001 second to 2000 seconds. I support bin 1, bin 2, and all the properties that are supported by the camera will be defined. So we'll do the other entities on the bus, including the agent, because the client will not talk directly to the camera and to the filter wheel. It will talk to the agent, and agent will do all the things for the client. And once the client has all this information, he knows what can be done with the devices available on the bus. The client says, "Okay, I want to use the camera, I want to use the Phoenix filter wheel, and I want to use the Pegasus focuser. I want to focus the telescope. I want to take 5 exposures, 300-second exposure in length, in the red filter." And it says this to the imager agent, and imager agent, and then okay, I missed something here, and 15 exposures of 900 seconds in blue filter, and save the results for me. It will say this to the imager agent, and imager agent will start the execution of this, and the client can go on, can go offline. So everything is taken care of by the agent. Agent will collect the data requested, and at a later point, when the client connects again, it may ask about the status, or it may get real-time update what's going on the bus, or if it's ready, he can just download the images. He can just download the images, and this is it. So the idea behind Indigo is that everything can be programmed and let alone to operate on its own. So something like an automatic observatory or something like that.
Mm.
So here's what the Indigo architecture looks like. We have devices here. Those devices are connected to Indigo via drivers. This here, and drivers are organized by the agents. We have mount agent, imager agent, alpaca agent is something interesting that makes the communication between ASCOM on Windows and Indigo. It's achieved via alpaca protocol. And we have some protocol adapters here, like JSON adapter, XML, HTTP, and stuff like this. But this is we are not going to discuss these things. So we can work with Indy framework natively. We can work with ASCOM using Alpaca, and we can obviously work with Indigo itself. So it's multi-platform and multi-framework. Indigo is multi-platform and multi-framework, if I can say that. Okay, so Indigo drivers are 3 types. They are dynamic drivers. They're characterized by the fast communication. They can be dynamically loaded and unloaded. There are static drivers that can be used in a monolithic application. For example, your application will have the driver in itself. In the single executable, you can add the driver. The communication is very fast also. And we have executable drivers. These are old style drivers. We don't use them very often in Indigo, but this is done for compatibility with Indy, because Indy loads the driver this way, and we can load Indy drivers into the Indigo, and this is the only way we can load these drivers, because this is the way Indy does it. On top of the drivers, as I mentioned, we have agents. Agents are like high-level drivers that provide application business logic. Agents can communicate between each other. They can access device through the device drivers, and they can translate Indigo messages into specific commands to provide unified interface to all devices. Drivers are simple. They're only capable of basic operations like get an exposure, set the gain, and things like that. But they cannot do complex stuff like get 100 exposures with let's say blue filter, and then switch the filter to red, and then take another 100 exposures and things like that. Those things are done by the agents, and the drivers themselves cannot communicate between each other. The communication between the drivers is achieved through the agents. So this is the difference between the agents and the drivers. They live on the same bus. They're pretty much the same. They have the same structure, but the only difference is that one talk to the hardware and the others talk to the other drivers and to the other agents and to the clients actually. So we have different device classes. We support mounts, cameras, guiders, focuser, filter wheel, DOMs, and pretty much everything you can think of. And we have some auxiliary classes like joystick. You can move your mount, for example, with a gamepad, like the computer ones that, or like Nintendo or whatever it is. You just plug it in your computer,
Okay.
and you can control your mount with those things. We can control external shutters, power boxes, sky quality meters, dust caps, light boxes, weather stations, and general purpose input-output ports of, for example, Raspberry Pi devices and similar. So the agents are the high-level drivers, and we have imager agent, which is responsible for taking exposures. Guider agents, which is responsible for doing the guiding, dithering, and things like that. Mount agent is controlling the mount and the dome. Scripting agent is something very interesting, which I'm going to show you later. We use JavaScript or ECMAScript to manipulate the properties in Indigo, and using this technique, using this agent, we wrote very powerful sequencing infrastructure, and I'll demonstrate it later. We have astrometry agent and ASTAP agents. Those agents are responsible for plate solving. You upload the image to the agent, and the agent gives you coordinates of the image and some additional data about the image after the plate solving. And we use the engines of astrometry and ASTAP. Unfortunately, ASTAP is not supported anymore for different political reasons, but astrometry is still here, and it works pretty well. Auxiliary agent is the agent that controls the dust caps and all the devices like weather stations and things like that. Alpaca agent is the agent that is responsible to export the Indigo devices to ASCOM, so that ASCOM programs like Nina or APT can use Indigo devices just like their ASCOM devices. Configuration agent is agent which stores different sorts of configuration. You can save different profiles, and you can make even a snapshot of a system with all the devices connected and all the temperatures set to the cameras and things like that. And you just load this configuration, and the system in 5 or 10 minutes will be configured as you want it. I say 5 or 10 minutes because, for example, if you set the cooler set to -20, it will take some time to reach that temperature. But anyway, you can configure and save all this information. You can just load this configuration, and you can get the system as you shut it down the last day. Snoop agent is obsolete, and the LX200 agent is obsolete. LX200 agent was responsible for receiving commands like mid LX200 protocol. This is because many Stellarium programs can speak this protocol and can control the mounts, but not all mounts can speak LX200. But we moved this functionality to the mount agent, and now you can just tell your planetarium software to point to the mount agent, and the planetarium software will move the Indigo controlled mounts. Indigo server is a piece of software that provides access to the drivers, to the agents, and it provides some additional things like service discovery. It will manifest itself. It will advertise what services it provides on the local network, and the clients can discover those things without the need for you to enter the network addresses, to enter the network names or things like that. It will just automatically discover all the servers and all the devices that are available on the network via this protocol. The server can load and unload drivers and can operate in headless mode. As I explained, it can the client can connect, can upload a program and can disconnect from the server, and then can go online again just to download the data that server collected. The clients in Indigo can connect to the Indigo server and control the remote devices. Clients can also load the drivers in themselves and operate without the server, but the devices that they use will be available only to the client. They will not be advertised on the network. Clients can act like Indigo servers also. If you link the client with this functionality from the Indigo framework, the client can re-export these devices also. And the clients usually provide user interface to control the whole infrastructure, and usually they're very stupid in terms of they're not intelligent to do complex stuff. They just know how to say. They just say, I need this and this, and the agent will translate this and will arrange all these things in commands that are that the server and that the clients that the drivers can execute. So there is no business logic in the clients. They know how to display image, they know how to request exposure, they know how to change filter, but nothing more than that. Everything is achieved. For example, guiding is achieved also on the server side. So the client knows how to start guiding and how to visualize the graphs from the guiding, but not how to guide itself. Indigo is supported platforms. It can run on Linux, Mac OS, and Windows. and can run on both Intel and ARM Linux. It can work on Intel and Apple Silicon, which is also ARM Mac OS. And currently, the version 2 of Indigo can run only as a client on Windows. But now we are working on version 3, which will support all the Indigo infrastructure on Windows 2, both on Intel and ARM Windows. And we'll have all the drivers available on Windows too, so you will not need to run Linux or Mac OS to use Indigo in any way. We also provide a operating system image called Indigo Sky, based on Raspberry Pi OS. Which is optimized for Indigo, and it comes pre-installed with all the Indigo drivers, servers, and stuff like this. It's more or less a plug-and-play device. You plug the power in this device, you connect your hardware, you open your web browser at indigosky.local at port 7624, and it will open you an interface. You can load your drivers, you can do whatever you want, and you can connect with your clients to this small box and do everything from Windows, from Mac OS, and things like that. You can put this on your telescope and have your laptop inside in a warm place, for example, if it's a winter outside, and do your things, and then disconnect, let it run for the whole night, and in the morning you just connect and download your data. And this is about Indigo. So now I'm going to present what is new in Indigo framework since 2023, since I since the last time I was your guest.
Okay.
Well, there are many things that have changed, and one thing is the focusing. We have more efficient and accurate and robust U-curve algorithm, which I think is a bit better than the other algorithms, because we learned from their mistakes, so to say, and we did it a little bit better. We have multi-star focusing. We can focus on many stars on the frame. This minimizes the effects of the seeing. We can use backlash overshoot strategy. This is a strategy that you don't need to be very precise with the backlash of the hardware, of the focuser. You just give basic backlash and an overshoot with how much it should overshoot, and with some additional movements, you can always predict where it will land, because of it will always clean the backlash on one side of the focusing, so it will always land at the same position, no matter if you move it inwards or outwards. And we have an experimental feature that can be used with the Bakhtinov mask. You can do automatic focusing with the Bakhtinov mask, which is something new and experimental and needs some polishment, but soon it will be normal feature. What else? We have implemented different dithering strategies. Until recently, we had only random, which is shown on the first picture. You give it the amount, and it will deter this amount of pixels at random, which is good for fixed noise patterns like the fixed pattern of the read noise, but it poses some challenges to when it comes to if you want to make some drizzling, or if you have some walking noise and streaking and bending. This is not very good, and it turns out that the spiral strategy, which is shown on the second screen, on the second diagram, is very good with these types of problems in the images. So if you use this, it will be a lot better, and it's very good for drizzling. If you do drizzling, this is almost a must. And combining the two, random and the spiral, we came up with a solution which takes the best of both worlds, called randomized spiral, which combines the strengths of both algorithms, and without additional cost, almost without additional cost. You don't sacrifice anything here. And actually, this is now the default dithering strategy. So something new is that we have this Indigo server controller. You don't have to type the commands on the command line if you don't want to, and you can start Indigo server with this GUI here. I'll demonstrate it a little bit later. And some MISC features. Finally, we have Meridian Flip that is synchronized with imaging. For example, if you want if the mount has to flip, the exposure will stop, and it will not continue if there is no time to fulfill the next exposure. It will stop, it will wait for the flip, and it will continue after the flip, so that it will not ruin your exposures. We added field derotation for alt azimuth mounts, so you can take long exposures with those mounts. It will automatically derotate the field for you. Obviously, you need to have a rotator for that. We implemented filter offsets for focusing compensation. If your filters are not parfocal, which is usually the case, you can figure out the offset of the different filters, and then you can enter them in Indigo. And every time when you change the filter, it will apply this backlash not backlash, but this offset for you. We added some additional features like include and exclude regions for focusing and guiding. I'm not sure how good this is, but there are many users asking that, for example, that they want to focus on the center. Others don't want to focus on the center, but want to focus on the periphery. And that's why we added this region, so that you can define where to look for focusing and guiding stars, and and which stars to use actually in which regions. So some users claim that it's very, very useful. Okay, so we have it. So we defined strategies on how to proceed. This is very important for the automated operation. How to proceed when the focusing or guiding fails. Yeah, it will just fail. It will wait for the stars to reappear, or it will try new stars and continue. So it depends on what you're trying to achieve. For example, if you're doing photometry, you don't want your stars to move around the frame, so you stop dithering, and you will probably use the strategy wait for the stars to reappear, because it will keep the stars at the same position. It will, if it drifted, it will move the stars to the same position, and then it will continue with the guiding. It will not try to find new stars and start from with the drift. So we refactored all the agents for more efficiency and for better maintenance. And we changed the polar alignment a little bit. Which is more forgiving. Until very recently, we had a limitation of 5 degrees. That if you are more than 5 degrees, it will fail from the pole. The polar alignment procedure will fail. But now it's more forgiving. You can have 10 degrees, for example, for this, and if your mount can go in azimuth and altitude for 10 degrees, you can achieve your polar alignment. And also we made a lot of bug fixes, and it's worth to mention that a lot of hardware support came out. Virtually every new device that appeared, we have support for that. We have new drivers for ZW mounts, for the camera angle adjuster of ZWO, for TubeTech and OMs like Altair, Astro, Omegon, and other brands that use TubeTech hardware. We added support for their focusers and filter wheels. We added support for the QHI focuser. We support all the devices from AstroAzis, their filter wheel and their focuser. We added support for Wonder Astro products, their rotators, flat panels, covers, power boxes. So, as I said, we support almost every hardware that's on the market now. This is a huge improvement. And what's new? What's new? We have, as I mentioned before, this advanced sequencer, which can do many things, and it is written purely in JavaScript using the scripting agents. And it has features like you can load and unload drivers with this. You can start Indigo and like a bare server, and you can load the drivers. You can select the devices. You can you have multi-target support. You can change the target during the sequence. You have execution flow control. You have loops. You can loop some operations. For example, you can loop, go to this star, observe it, then go to the other star, observe it, then return to the first star, and things like that. You have delayed execution. Like you can say, I want you to start at 10 p.m. and execute this sequence, and on the next day at 10 p.m. start and execute the same sequence, or execute something else. So you can program this. It's not a true scheduler, because you have to do the schedule yourself for the time being, but it's a step toward the automated scheduler. So almost everything can be automated, and I'm going to make a presentation after of this feature after this presentation. So yeah, this was about the Indigo framework. Now I'm going to show you some new features in the Indigo Imager, which is the client. Well, it supports field rotators, with including the field derotation. This is the screen. You can turn this knob here and rotate and set the new angle for the rotator. You can start the rotation. It will give you a parallactic angle, and you can give you the rotation rate, which will be used to derotate the image, and things like that. I recently added, actually last week, I added a feature for the polar alignment that many users asked for, which is they wanted some sort of visual aid how to for the polar alignment, because we have only this part here. I don't know if you can read it, but it shows you the error and gives you instruction: move counterclockwise with some amount and move down with some amount, and things like that. But users tend to like visual representation of this, and that's why I added this target with color-coded errors. If the error is small enough and it's good alignment, it will show in green. If it's a little bit larger but still acceptable, it will be yellow. And if it's too large, like in the example here, it will turn red. So you just need to do some more adjustments to that. So this is something very fresh. I released it yesterday, actually. And the advanced sequencer. I'm not going to spend a lot of time on this slide here because I'm going to show you. I'm going to show you how this works in real life, and how to construct such sequences. And what's new for Apple? Indigo works on Apple too, and now we have big news: iPhone and iPad applications, with which you can control Indigo server. You can see here the imager part. This is on iPhone. This is on iPad. You have pretty much all the controls and all the information you have on other clients. This is the guider window. You can see the guider graph, how the guiding goes on iPhone and iPad, and also the Mac client, which we had for a long time. And now I'm going to give you some update on what we are working right now, what will be new in the near future, and not very near, unfortunately. Upcoming Indigo 3.0. Probably something like 6 months to an year. We will have Indigo 3.0. We already migrated something like 20% of the drivers to Windows. It will provide native Windows support, and will become a competitor to ASCOM, direct competitor to ASCOM with this move. We'll have all our hardware working on Windows. We are working on something new, which is auto-generated drivers. This is a new interesting concept because a lot of the driver code is just a boilerplate. 60 to 80% of all drivers share the same code, and there are only, for example, 40 to 20% which is device-specific code. So using this, we decided that we can make an auto generator. We just add some tags and say, well, on update of this property do this, on update property do this, and all the internal stuff will be handled by this code generator, and it will generate the code for the driver with the additional things that we add in this template. And it will generate it will generate all the drivers. And another benefit of this approach is that if we have a bug in this boilerplate code, we can fix it in one place. Excuse me. We can fix it in one place, and we can regenerate all the drivers, and we'll have it fixed in all the drivers. Because as it is now, we have to touch every driver individually. We have more than 100 drivers, so it's if we find some bug like this, it's a pain to fix. So this is something new, and it will help us to maintain the code better and to be more bug free. Another thing that is coming with Indigo 3.0 is bidirectional communication for multi-server setups. Now the servers can act as clients and as servers. So at this point, you can connect, for example, 3 servers, but you need one server to combine their buses. And with 3.0, you will not need this. Each of these 3 servers can act as will combine the buses in itself, so you can connect to each of these 3 servers, and the 3 of them will see the same devices. I hope I explained it well.
Yep.
Okay. And we'll have more efficient client and server communication. For example, when you request property enumeration, as I showed in the example in several slides before, if a client asks who's on the bus and requests property enumeration, this enumeration will be sent only to the client requesting it. because now it's sent to all the devices, so it may become a bit cluttered if many clients are on the bus. And the last but not least is the Indigo scheduler, which will be an upgrade of the advanced sequencer. It will have all the necessary features for a good scheduler. It will have observing blocks. You can define the block of for example, how would you like to observe some object or some target, and you can define this block about this target with what filters, how many exposures, and things like that. And it will automatically select between these blocks depending on different criteria like best visibility, priority of the target, and some other things, and it will arrange those things. And when this block is completed, it will put it in completed state, and it will continue the next night with the next one. So you can arrange, for example, schedule. You can arrange this. You can upload such observing blocks for 2 weeks in a row, and you can let Indigo in, and in 2 weeks it will find the best way to observe these objects if they are visible, for example, and if the weather was not too bad, so you had enough time to complete it. And this was it from this presentation. Now I'm going to do some demo. Are there any questions? Anything you want to ask? And
I thought I saw one. I thought, Eric, you put one up.
Yeah, I did. I was just curious because now you're saying you have coming up a native window with Indigo 3.0. It'll be something that's more Windows native. Was Indigo always originally when Indigo was designed? Was it based off of the Indy framework, or was ASCOM ever involved with it? Or and then you moved towards ASCOM sharing the ASCOM framework a little bit later, or was it originally built for Indy, for the Indy protocol?
Actually, we with Peter, we were Indy developers, and we wanted to enhance Indy in the way that we developed Indigo, but the community didn't share our opinion, and didn't share our ideas about things like hot plug devices, about dynamic loading and unloading drivers, about agents. This is very important, and about more efficient image transfer, because the base 64 encoded images, because Indy transfers base 64 encoded images. And we decided to start something new. And basically, Indigo is originally used Indy properties to operate, because we wanted to use the clients that are available for Indy with our framework, and that's why we made it compatible so that we can load Indy drivers in itself. But it doesn't share the code. It shares only the protocol, and it shared it. But as we evolved, we developed our own protocol, and we cannot use Indy, because Indy is limited, and they do not have the things that we need to progress. For example, we made image transfer in orders of magnitudes faster, because we don't need to encode it in base 64, which is 30% larger, and then decode it on the client when it arrives. So we encode it. It becomes 30% larger. We transfer it over the network 30% larger, and we decode it on the client. We did the opposite. We can transfer the image in a binary form without any additional things. And we can even compress the image with lossless compression. I mean, like zip or something like that. It depends on how you configure your server. We can
Yep.
compress the image so that we can transfer even less than it was before on over the network. So in this regards, we are a lot faster than India and Alpaca also. And we moved towards the Alpaca. I mean, it's not ASCOM, but it's ASCOM Alpaca, which is something like a patch over ASCOM. So ASCOM is linked to the same machine, but you cannot access those devices from another machine. And this is an attempt from ASCOM to become network aware and to expose their devices over the network and to use to be in the new era, for example. And they developed this protocol. And what we did is we export our devices anyways to the network. We just did a transition, a translation layer. The Alpaca agent translates Indigo messages to Alpaca and Alpaca messages to Indigo, and nothing more than that. We don't interact in any other way with ASCOM. And
Gotcha.
ASCOM applications know how to send Alpaca requests. They come to our agent. Our agent translates them to Indigo. Indigo does its work and returns the result back. And what we'll do in version 3.0 is to bring the Indigo infrastructure, the Indigo drivers themselves, and the communication between the driver and the hardware to be on the Windows host machine. So you can plug your devices in the Windows machine and use your client, for example, on Linux or another Windows machine or the same Windows machine. Because as it is now, you can plug your hardware on Linux or on Mac OS, and you can use clients on Windows, but not the devices on the same Windows machine. So this is what we will achieve with the version 3.0.
Is in your opinion, do you think it would be better to just go with a Raspberry? Because I do see that you have that this is, we can download this directly into, the Raspberry Pi, and that's how Indigo Sky is basically developed. Do you recommend that versus as a better alternative than utilizing a Windows and then a Windows box and just just take Windows out of the equation?
Well, initially the idea behind Indigo was to bring the astrophotography, and not only astrophotography, but Indigo is used in several professional observatories all over the world. Is to get rid of Windows, to be able to operate on Mac and on Linux.
Right.
And this was the initial idea, but now as we progress and we have more users, we get more and more requests that they want to run it on Windows only. And we thought that we can provide that also. If somebody wants to use it, let's use it on Windows. I cannot say anything is better than something is better than the other. It's what suits you best. I mean, it's so flexible that you can run for example, you can run your mount on one Raspberry Pi, and you can run your camera on a separate Raspberry Pi, and you can run, for example, your filter wheel on the third Raspberry Pi. It's up to you.
Gotcha.
I mean, it's distributed, so you can control, for example, 3 different telescopes. You can just put next to the telescope Raspberry Pi devices, and you can make network access to these observatories, and you can control them, the 3 observatories at the same time using Indigo. So the basic idea behind Indigo is to be distributed and to be efficient and to be platform independent. And for the time being, it's platform independent on the client side, but not really on the server side, because we are tied to POSIX. It's Unix-like operating systems like Linux and Mac
Yeah.
OS.
Okay. I
Does that
follow you.
answer your question? Or
Yeah. No. That does. I follow you. So no,
okay,
because I'm just thinking, of alternatives versus, always being dependent on a Windows box, But I understand the
yeah,
need,
yeah.
but if you have customers, and that need in the market, more and more people, yeah, they're more Windows dependent anyway. So it makes sense to build that, that Windows framework
Yeah,
too.
we had a lot of requests to for that, and we said, well, why don't we provide it? It's it turned out to be more complex than we initially thought, but we started it anyway.
Well, that's Windows.
So there's yeah. Yeah, well, Peter, the other guy, we are two of us. The core team of Indigo is me and Peter, and Peter is more of a Mac guy, and I'm more of a Linux guy. So
Right.
we kind of complement each other, and none of us is a Windows guy, And now we are learning by doing.
Yeah. Yeah.
Am I saying it
Exactly.
correctly? But
Oh.
well, this is how it is.
Yeah. No.
So now we know how to do it, but it's pretty complex. I mean, it's many things are different. We migrated the core infrastructure. We migrated the core infrastructure to Windows, which is very good, but we have difficulties with some drivers because we either don't have an SDK for the drivers, and either we have to uh, rewrite some substantial part of the code, because it's very platform dependent, written for POSIX operating system, which both are Mac OS and Linux, and things like that. But this is only in the driver part. Mm, the core of the Indigo, we already made a transition, and it runs on Windows.
Gotcha.
Any
Okay.
other questions?
I don't think so. I think that was
No, I don't
it.
think so. I think that was it.
Okay, so I can show you how it works. I can show you the sequencer,
Yeah.
how to make a sequence, and some things like that.
Yeah, lot
So
of
I
people
hope
want
I
to see
can.
it in action a little bit. So
Exactly. Yeah.
Yeah,
That's what a
this
lot
is
of
what
people
I'm
want to
going to
do.
show you.
awesome.
Yeah, this is what I'm going to show you now. Okay, so I'm going to minimize those windows, and this is the server manager. I'm not going to start the server from the command line. I'm going to show you the new tool. So here you can load the driver, you can list the drivers, but if you're lazy and you don't want to write them, you can access all the drivers. It enumerates all the drivers available, and it puts them in this menu here. So you can load, for example, agents, you can load auxiliary drivers, you can load, for example, GPS. Let's load the GPS simulator, and it appeared. You see it just appeared here. You can choose the service name by which it will be discovered on the network. As I said, as I explained you, Indigo provides network discovery. So the client will automatically discover this service when we start the server, and the service will be called Vega, because the host name of my computer is Vega, but you can type whatever you want here. The default port is 7624, but you can change it, and the log level, for example, info level is okay. Error is only the errors will be will be printed, and debug will print some additional debug messages, like very like messages between the devices, and the device specific messages and things like that, and this window will be very cluttered, so we don't want to use this here, but it's helpful when you have some problem. We will probably ask you to go in debug, trace bus, or trace mode, and run the application, and then save the log for us, and it will save all the log from Indigo, and so that we can analyze it and we can figure out what was the problem and eventually fix it. And we have some other features here, like disable service discovery, disable blob buffering, and I'm not going to explain all this. And this is enable blob. Blob is binary large object. It's basically images, and this is what I explained you. Enable blob compression. If I click here, all the images will be transferred compressed, and it will be something like 50% of the image will if the image is 50 megabytes, it will go on the network something like 25-30 megabytes usually, and sometimes even more, even less. I'm not going to enable this, and I'm going to start the server like this. Okay, we have all the devices here, all the simulators here, and we have the service started at vega.local at port 7624, just as we asked it here. And now I'm going to start the imager. Okay, imager. Okay. Here's the imager. Actually, we can minimize this window. We don't need it at this point. And we can choose our device like filter wheel simulator, for example, guider camera simulator. We can hit preview, and we have an image here. So let me just quickly show you how it works. This is the new thing that I added this week, this polar error target, or whatever it is. It's
Your polar
visualization. Yeah, for the polar alignment. But it will not work this way. We need a mount for this thing. And at 90 degrees, it will not work. It doesn't need to. So let's try this, and let's say 13 here, so that we are close to the meridian. And hit go to, and the mount will go to wherever we pointed it. And I'll just quickly show you how the polar alignment works. Okay, so we are 11 degrees above the horizon. Okay, this is good. Okay, and hit start alignment. Here we will use exposure of 1 second for plate solving, and we'll use 20 degrees of hour angle move in right ascension, basically, and it will make 3 measurements, and it will give us the error. We can start alignment. It plate solved the first image. Now it moves to the second position. Okay, plate solved the second one. Now moves to the third position. Oh, we are below the horizon, but anyway. So we have an error of 878 and 878 minutes in azimuth, and 2 minutes and 2 minutes, 2.3 minutes actually in altitude. This is because of this map that we draw, this simulated map, is in J2000. So this is actually the precession. Well, we can correct this. For example, I can just show you how it works. We can go to the guider simulator here, camera main, and here we have some things that we can fix. For example, we can go and say 0 here, which means the current epoch J now. I'm not pretty sure it will work like that, but let's try. Probably it will. Yeah, it will not work this way. We need to start alignment from the very beginning, because this is not an error we can correct. It's another type of error. But anyway, we can start alignment. Yes, well below the horizon, but it's a simulator. Should work. Yeah, well, I just didn't bother to bring it above the horizon. You see, it's minus 36. It's looking somewhere below the horizon. But yeah, and now we have a lot small. Well, the error is almost negligible here. And this error is because this map is not very precise. It's something like 8 by 8 degrees, and the resolution is not very good. But still, you see that we are pretty close to what we need. But we can fine tune it. For example, it needs 136. We can just do like this, -1 here, and -1 here. And probably it will go better. I hope. If not, it's in the other direction. Recalculate, and there you go.
There it is. Yep.
Dead on.
We're polar dead on. Yeah.
Yep.
Yeah, but usually you achieve this by rotating the azimuth and altitude knobs on the mount.
Yep.
Right.
Yep.
Right.
Yeah. But yeah, it shows you what it needs. So we are going to stop this. We don't need this anymore. I'm going to close this, and we are going to. Since we are here, let me show you the rotator. Yeah, we can just add the rotator here, and so you can go to 65 degrees. We can go like 65 degrees, and it will move to 65 degrees. Oh, it's 66. Okay. Anyway. And we can start the rotation, and you see how the angle changes with the time with this rate here. This is the rate, and it will keep the rotation, keep the same rotation for the alt azimuth mounts. Okay, so this is something like a side. The main focus of this demonstration is this part here, the sequence. So here we have this area where we can arrange our sequence, and we can do, for example, first we can enable camera cooler and say we want the camera to be cooled to not like this. First we need to select the camera if we don't have it. We have a camera selected here, but we don't want this camera. We will just use the imager simulator. So we go to devices, select imager camera, and we can choose which camera we need. All the devices will be listed here, as I mentioned, and we will use imager simulator. And we want to set the temperature. We will not bother to set it to 0 degrees, for example, because 0 degrees will take too much, and we'll say like 23 degrees, because it's 24 by default. And now we can say we can select mount, because without a mount devices we can select mount, and we can say mount simulator. We have already selected the mount simulator, but for the sake of completeness, I'm showing you. If we don't select the mount, it will use the mount that we have selected here. So, and if we don't select focuser, it will use the focuser we selected here. And everything is like, I mean, if you don't specify device here, it will use the selected in the user interface devices. But anyway, so we select the mount here, and we say mount slew to, we can choose, we can enter right ascension and declination here, for example. But we can do something more clever, say Rosette Nebula, like this, and it fills our coordinates of the object here. And we need to set some object name so that it will appear in the FITS header, and that it will appear in the file name. It will be a prefix of the file name. So we'll say Rosette like this. And okay, we have everything set up here. For example, we can start guiding, we can add focusing, we can, let's say, enable meridian flip. Let's go like this and say enable meridian flip. And we have enable meridian flip, and if when the flip occurs, it will, if we check this, it will do it will use the solver to precisely center at the same spot after the flip. If we don't use it, we'll use only go-to. And here we have also precise go-to, like mount precise go-to, which uses the same thing. You can specify the exposure time for the solver, and write ascension declination. It will center using the solver. It will center the object using the solver, but we are not going to do this here. Okay, so we have pretty much everything. And now what we can do is start the imaging. For example, we can capture batch. We'll say we want 2 exposures, 6 seconds. And we need to put it, oh, we forgot the filters. So we need to select the filter wheel, probably somewhere here. Well, we can right click somewhere and it will show this line, and it will show us where the operation will appear. And now we choose select filter wheel, okay, and go here and say imager simulator filter wheel. And now we can choose select filter, for example, select filter, let's say red filter, or we can choose like green filter or H alpha, let's say H alpha. So we want to get 2 images of Rosette Nebula in H alpha as it is now. And when we are finished, we can say select. We can say we can deselect all the devices, for example. And also we can say like when the temperature is reached, we can go here and we can say wait until, and we can, for example, say it should wait until 2025, 29th of May, 1 o'clock and 19 minutes, and it will resume operation at this time. So with this thing, you can make your program for several days, for example. So I'm going to remove this, not going to show this right now. And okay, so we have a sequence. So let's start it and see what will happen. Okay. Started the cooler. Let's see. It's 25, still at 0, 24, and it's 24, 23, and it should continue at some point. Yeah. It selected the mount, selected object name, and okay. There you go. Oh no, we have one more image to do. Okay. Here it is. We have everything now, but what if we want to loop this thing here? We will loop select filter and capture batch. We can just go here. You can go to flow control and add repeat section, and just drag select filter and capture batch. And we can add, for example, here select filter, another filter, and say H alpha and O3, and then make another capture batch, and say we want 2 more exposures in O3, again 6 seconds, and we can just restart the sequence. Oh, we'll repeat it only once. I forgot to increase this number, but you get the idea.
Yeah.
You can repeat it as many times as you want.
Do you have like a repeat until time? Like, let's say I just want to run this.
No, we don't have repeat until time yet.
Okay.
We don't have this, but we'll make it.
Yep.
It's in our to-do list.
Nice.
So we have something else that I want to show you.
Yeah.
We have different strategies here, how to proceed on error. For example, let's say we want to select filter H alpha 2. We don't have such filter. And this operation will fail, and we will run again this sequence, and the sequence is supposed to fail at this point. There you go. It failed, and it says there is no option H alpha 2. So what we can do is, for example, we can set a strategy here, like flow control, like continue on failure. And when it comes here, it will fail, but it will continue with the repeat until it finishes. It will continuously fail here, anyways, but it will continue. So it's not a very good strategy, obviously. So I'm going to move this down here, not like this. Like I'm going to, let me just expand the window a little bit. I'll move this here at the bottom and put this and go to the flow control and say recover on failure. And by recover on failure, we mean that it will go to a section where it can continue with the operation. It will just skip the whole, probably the whole section which failed. For example, it doesn't make any sense to capture this batch here if we cannot set this filter. For example, if we have it, but for example, the filter will fail. And we can define recovery point. So let's go here and say flow control and put here a recovery point. So when the failure occurs, it will go to the next recovery point. We can define many strategies within the sequence, and we can define many recovery points. For example, we'll have at the end a recovery point, which will say simply park the mount, because we want to finish the exposure and probably stop cooler, capture disable camera cooler, and that's it. And when we finish with this sequence, it will park the mount and disable camera cooler. Or if something fails within this sequence, it will again park the mount and disable camera cooler. Let's see how it will work. It's supposed to fail here. Yeah, it failed here. Now it parks the mount. If we go here, we see that the mount is going to park position. It says parking here. It will park the mount and it will disable the camera cooler. Okay, it disabled the camera cooler, and there we go. We completed our sequence.
All right.
So this is pretty much everything. If you have any questions, if you want to ask something more. Oh, and I didn't show you. You can move things out and in the repeat. You can have as many repeats as you want. You can put another one here. For example, we have many different things like select frame type. You can select light, bias, dark, flat, and things like that. You can add, for example, you can start guiding, you can calibrate guiding, you can autofocus, you can focus, you can set focuser position, you can enable and disable temperature compensation so that you don't have to refocus when the temperature changes. If you enter some temperature, how many steps should be performed with a degree of temperature change, it will automatically compensate focus for the focuser position with this, so that you don't have to to refocus, waste time on focusing. You can set rotator angle and pretty much everything you need to do. You can do it from the sequencer. You can select devices as I showed you. You can enable and you can set some things to fits header. You can remove keywords from the fits header. You can load driver, for example. And here you type the driver name and things like that. So everything can be automated and everything can be done independent of. I mean, you can start this and you can go to sleep.
Nice.
And you can even stop. You can even kill the iron client. And now when we go here and when we go to sequence and when we press this button here, it will load the sequence from the server, the one that is running on the server and that is uploaded on the server. And also we can save the sequence as a file. For example, let's save this sequence. Oh, this is load. It's not going to work like this.
Mhm.
So we can do like save sequence, like untitled sequence. Okay, good enough. Say, oh, I have it. Okay, so we save this sequence and we can load it here. Well, let me just load some other sequence. Like I don't know what it is, but okay, this is pretty simple sequence. But let's load the sequence that we just created, untitled sequence. Open and you have it.
Yep.
So you can do all these things, and this sequence actually looks like a regular JavaScript. Let me show you. Open. Do we have another document, and we'll go here. It's untitled sequence. Okay, open, and here's the sequence. Recover on failure strategy. Select camera. Select enable meridian flip. Enable cooler at 23 degrees. We can even make it like this. You can put it side by side so that you can see how it corresponds to the script.
Nice.
Yeah, and you can edit it here, and you can upload it. Then you can load it from here. You can edit it as simple text. Well, this is pretty much everything that I had to show you, and I wanted to show you. If you have any questions, if you have any things that I want to make clear, let me know.
Let's see.
Let me see here. I thought I saw one or two from Thomas.
I saw a couple of Microsoft questions.
Yeah. Use this to sync an array of C's. Minotaur was wondering if he could use this to sync any array of sea stars, like smart telescopes.
Not yet. We don't have drivers for these telescopes, and the thing is that the vendors are not very open to this. They don't want to provide the protocols for communication with these devices because they want to keep you in their ecosystem, and and it's hard to do this.
Yep. What about
Thomas
somebody?
was asking,
Go ahead.
with the expiration of Windows 10 later this year, many may change to Linux variants. Will I be able to run my system in one of these variants instead of Windows?
I don't.
He was looking at.
His Windows is expiring, right?
Yeah.
Yeah. Because Windows 10 is at end of life in.
Okay. So he can switch to Linux. He can switch to Linux and use Linux for that.
Yeah.
No problem.
He was
Actually, this works for Linux and Mac OS.
Mint.
Sorry?
I think he was mentioning like Linux Mint.
Yeah, Mint he was talking about.
Basically every Linux.
Okay.
Okay. Cool.
Yeah. Well, if it's for example, we don't provide RPMs, but it's easy to compile and install from the source code. It's just install it, follow a couple of instructions, type make, install, and it'll go. Everything will go in their places, and you just can run it. No problem.
Hey, Rumen, if you're done sharing your screen, if you could just click it off.
Okay, let me see how.
You can. You can. At top of screen sharing. There you go.
Yeah. Okay.
Nice.
Good.
So I know there was a question about that regarding Paramount mounts. They compatible with it? How does it, because they have to use the Sky X and all that.
Sky,
So.
yeah.
I'm not sure about Paramount Max. Mounts. I don't think we have support for them.
Gotcha.
But we can actually check on the drivers list. But I'm pretty sure we don't support them. Well,
I know they have an ASCOM
there's
driver, but I don't know if they have
Sorry?
something. I know they have an ASCOM driver, but I don't know if that's going to work. I'm not sure if it'll work or not.
Well, no. If they have ASCOM, we have nothing to do with the ASCOM driver,
Right.
so
Right.
it will not help us.
Yeah.
Yeah. Well, there are some vendors that are not very open, and they don't share their protocols and their way to communicate with their devices. And with some vendors, it's a bit tricky. And I'm pretty sure that we don't have a Paramount driver. Yeah.
Gotcha.
Yeah, I know it's they're kind of like one of those couples that kind of want to stay within their own ecosystem as well.
Yeah, we
So-
also don't have for ASA.
ASA?
This
Yep.
ASA,
Yeah, ASA mounts.
Austrian.
Yep.
ASA mounts. They just refuse to provide us with the protocols for their mounts.
Yeah.
Gotcha.
Although we have one telescope in our observatory, 1.5 meter telescope they made, and they just refuse to give us the
Wow.
protocols. So we can control our 2-meter telescope with Indigo in our national observatory, but we cannot control our new telescope with Indigo because of that. But this is how it works. I mean,
Yeah.
yeah.
But,
All right. Well, thank you. Really appreciate it, Rumen. I know we're just about at time or a little bit over.
That's okay.
So again, thank you so much for sharing your updates with us on what you've got going on with Indigo Sky now, and what you got coming up soon with Indigo 3.0. So really appreciate that. Also, everybody, don't forget, Image of the Week is out there. We have 3 images under the experience bracket. Unfortunately, we still don't have any novice entries this week, but don't forget to tell your friends, to drop one in for the next for our first June Image of the Week contest. Yep. So this will be our last one for May. Then we'll be kicking off the Image of the Month for May. And next week we'll have our first Image of the Month for June. So don't forget to put one there. Norm, no, don't put one there in novice, because
you are not a novice.
You are not a novice. You don't count. But no, again, thank you, Rumen, for your time, and really appreciate it. And yeah, definitely check out. Where can they find Indigo and Indigo Sky? Where can they find more information?
It's on the Indigo/astronomy.org.
Okay.
On our
put
website.
It in there. Indigo.
Yeah. So let's drop that in there into the chat.
Yeah. Indigo/astronomy.
Okay.
.org.
Yeah. Yep. Indigo.
You can try it in the web browser first.
Yeah, I'm gonna try it there first.
Yeah. Indigo-astronomy.org. So definitely go check that out. Check out Indigo. He has quite a few downloads there for and a lot of information as far as software and hardware compatibility. If you want to check that out for maybe your Raspberry Pi. If you have a Raspberry Pi, you can definitely check it out and download it and install it. He's got all the instructions there. So again, thank you so much. Don't forget to meet us on Friday. If you like this type of content and these presentations, please don't forget to give us a big thumbs up. Give a big thumbs up for the show. And leave comments in the comment section and everything. So we would really appreciate that to make the show better.
And
we're going to leave now.
when 3.0 comes out, Rumen, we got to have you back. No more of this
Yeah.
2 year
Yeah,
stuff.
definitely.
No more of this 2 year
Yeah,
stuff.
yeah,
You don't
yeah,
get off
definitely.
to any easy. Maybe we'll do it on a weekend so you could get some sleep.
Yeah, sure.
Okay.
Sure.
Okay.
Yeah. So yeah, again, yeah, I know it's pretty early in the morning there, or
That's,
probably
Well,
like
it's
3 or 4 o'clock in the
4:35.
morning.
it's
Yeah, it's
time to get
already
up.
almost dawn. It's almost
Yeah,
dawn.
I have something like 3 hours to sleep and then go to work.
Oh my
There
goodness.
you go. So yeah, so we're not gonna hold you up any further, but we want to get some final thoughts. Dave, final thoughts?
I had a quick question. You said you had your little all-in-one little box. What's the price range on something like that?
Actually, the price is you buy the Raspberry Pi, you buy the box, and you download it from the website, and it's at the cost of the box and the Raspberry Pi that you buy. It's free.
Okay.
Everything is free. I didn't mention, but everything for Linux, Windows, and for Raspberry is free, and only the clients for Mac OS are paid, but they're something like $10 a piece or something like that. I'm not sure. Peter knows better
Okay.
because he's maintaining them. I'm responsible for the Linux and for the Windows part.
Gotcha.
Cool. Well, I'm excited to see how it goes, especially with the new update.
Yeah. Mr. Scott.
Yeah, very nice presentation.
Thank you.
Really learned a lot about the process and such. I am not going to hold you up. I see it's late, so head to bed.
Okay, if you have any questions, I'm here, so you can ask.
Dan.
No, again, Rumen, thanks so much for coming down and hanging out with us
Thank you
again
for
at
having me.
early mornings. Just on a side note, we got 2 more guests coming up. We got Tom McCrory coming up on June 4th. He'll be going over his software, Pick Astro. So if you want to check that out, that's picastro.com. And I believe on the 25th of June, we're going to be having Sarah Matthews back, Sarah Maths Astro. She's going to be back to hang out with us. She was on Astropalooza last year and had a little blooper reel there. And, so she's coming back with a vengeance to show her what she's got going on. And Ruben, I don't know if you're interested, but if you're interested, we do a thing called Astropalooza on the first Saturday of December. And don't get scared. It's a 9-hour live stream that we do every year. And it has up to about 13 or 14 half-hour or so presentations from different people all over the world. We've had Dylan O'Donnell, Trevor Jones, Masters of Pix Insight, a bunch of other people, David Geeson. We've had a bunch of people.
Sass, yeah.
Dr. Sass.
Maybe I can join with Indigo 3.0.
There
Yeah.
you go.
There you go. That would
there
be
you go.
great.
That might be
Perfect
perfect
time.
timing. So I mean, I
So
think
now you have to have it ready to go by December.
Yeah, well, our plans are about 6 months, but we'll see.
so. It
Okay.
looks like right now it's going to be December 6th. It might be the 13th, depending on when the Army Navy game is for Eric. But so we're trying to work around the football schedule. So, but if you're interested, let me know. I'll slot you in for a half an
Well,
hour.
if I have something to present, and probably I will have something, so
Yeah,
why not?
all right, you're in.
All right.
Thank you for your invitation.
Yeah, I'm gonna write you down right now because you're my first one. So,
You got
Rumen,
me.
You got you.
Astropalooza.
There you go. Get Rumen down.
There you go. You're in.
All right.
So
So
we'll try and
Something
do you
like that
because
to go.
we'll try and do you like first or second, so it's not so late. So we usually start at about 12 Eastern, so it'll be
Yeah,
about
something
dinner time for you. So
Yeah, it's fine.
so
I mean, I usually stay to very late because I'm working on Indigo on my spare time usually after my wife and my dog go to bed. So
I can't
I
believe
usually
you're
start
so
about
animated
10.
at this late. I know it's 9:40 in New York, and I'm ready for bed. There's no way. I'm exhausted.
I know. Usually, what I do is when I go to bed, I have the telescope on my balcony because I'm in the city, and I put it on the balcony and start imaging and start doing something on Indigo.
Nope, there you go.
Or testing something on Indigo with the telescope, and then go to bed at some point. Then wake up in the morning,
Look
put
at
the
the data.
telescope in because I don't want to have some rain on it if it rains or something, and go to work.
Yep.
There you
So,
yeah.
but
So that's all
actually,
I got.
right now I don't have anything from my balcony, anything to image from my balcony because it's very polluted, and I mean it's border 7 sky here, so I can use only narrow band filters, and I have very tiny strip of.
Yeah, it's not that time of year right now. For now.
Yeah, not that time of year. So now I'm not doing it,
Yeah,
but I'm doing it during the winter and during the summer.
Yep.
Yeah.
Got to wait for the sharpness catalog to go up. So
yeah. Well, next, I think on Friday, maybe Dan will also do maybe a Masters of Picks Insight giveaway. We haven't done one of those in a while.
Yep.
So
get
maybe
back
we'll
to
do
that.
that as well. Get back to that.
Yep.
But again, Rumen, thank you so much for hanging out with us. Everybody else, thank you again. We really appreciate it. Don't forget to leave comments, thumbs up, and don't forget to also keep up with us on our Discord channel. If you have any questions, anything like that, or you're getting started and you want some tips and advice, don't forget to drop a line in our Discord channel. And if you even want your images, if you don't want to drop them into the novice, ranks yet, let us critique them. We look forward to even critiquing them in there as well. But again, we will see everybody on Friday. So as always, keep imaging, keep educating, and clear skies. And we will see you all on Friday. Take care, everybody.
See you, everyone.